In this video, I'm going to work through a few examples about linear equations. So first, the maximum recommended slope of a wheelchair ramp is 1/12. A business is installing a wheelchair ramp that rises 22 inches over a horizontal length of 24 feet. Is the ramp steeper than recommended? So the first thing I'm going to do is look for some keywords here. This is about slope, and 1/12 is the maximum recommendation. So I'm determining that I'm going to have to compare whatever I get to that maximum recommendation. Secondly, I'm going to draw myself a picture. This basically is a triangle where the wheelchair ramp rises 22 inches, so that's 22 because that's rise, over a horizontal length of 24 feet. Note, these are different units, right? So I need to get things into the same unit in order to be able, in order to compare them. Cool. Okay. So we know that slope is equal to the change in y over the change in x. So in this case, our change in y, which is height, is the 22 inches. And our change in x, which is horizontal, is the 24 feet. We need to figure out what 24 feet is in terms of inches. So just a quick calculation, 24 times 12 equals 288. So we have 22 inches over 288 inches. And when I put that into my calculator, I get approximately 0.076. This is a decimal. This is a fraction. So when I put 1/12 into my calculator to figure it out, I get 0.0, well, about 0.083. 0.076. This number is not larger, therefore the ramp is not steeper, therefore the ramp is fine. So to answer this question, I would say no. The ramp is not steeper. 0.076 is less than 0.083. Note, this statement is actually the solution. So remember, you are trying to communicate your information here. The work that you did is the it's the supporting evidence for your conclusion. Okay, moving on. A kitchen appliance manufacturing company determines that the total cost in dollars of producing X units of a blender is, here is our cost equation. Describe the practical significance of the y-intercept and the slope of this line. So let's talk about this for a minute. This is going to be the total cost of manufacturing, right? This is the price per item, and this is going to be our starting expenses. So in this case, how do I know that? First of all, I'm looking at this graph over here. The fixed cost is $3,500. That means that's the cost that it takes to pay my workers, rent my factory, etc. So I just got to pay that all the time. Marginal cost is the cost of the item. So for each item that I make, it costs me $25 on top of the $3,500 that I'm already spending. So when I combine those, that's how I get to the total cost of everything. So now I need to figure, I just said all that in words, but now I got to figure out like, how do I write it down? So pretty much you could just put in a sentence or whatever I just said. So 3,500, the y-intercept is the operating cost for having the factory. And it's what you must pay no matter what. What you must pay no matter. $25 is the cost per unit. Period. Okay, cool. There we go. Okay, let's move on and talk about straight line depreciation. So depreciation is what happens when something loses value. So for example, when you buy a car, it loses value the moment that you drive it off the lot. That's what they always say. So that you can't sell it again for the value. That's because you're using it. The same thing is true in your house. You buy a refrigerator for your house. It depreciates over time. If you're real savvy with your taxes, you can actually, say you had a rental property, you can actually deduct the depreciation of the equipment in the home, like laundry, dishwasher, refrigerator, etc., because the idea is that it is going to be worth less money over time. Anywho, so a college purchased exercise equipment worth $12,000 for a new campus fitness center. The equipment has a useful life of 8 years. The salvage value at the end of 8 years is $2,000. Write a linear equation that describes the book value of the equipment each year. Book value just means how much it's worth according to how old it is. So you might have heard people talk about Kelley Blue Book even when they're talking about buying used cars. The book value just describes what an approximate value the item has depending on how old it is. So let's talk about information. So in this problem, we've got actually 4 pieces of information. So a college purchased exercise equipment worth $12,000. So that means when it was new, or, zero time had passed, it was worth $12,000. Then it talks about the equipment has a useful life of 8 years. Salvage value at the end of 8 years is this. So we know that when it's 8 years old, it has a value of $2,000. Hell, these are actually coordinate pairs. 8 and 2,000 and 0 and 12,000. So from here, if we want a linear equation, what 2 things do you need to write a linear equation? You need a point and a slope. Do I have a point? Yes, I do. I have 2 of them. Do I have a slope? Not yet, but I can find it because I can use my slope formula and I can say 2,000 minus 12,000 over 8 minus 0. So in this case, we get negative 10,000 over 8. And if I put that into my calculator, I get negative 1250. Okay, so this is my slope. Remember, this is all money. So this is also money. For our equation, now I would just write, pause. Which point should I use? Should I use the green point or should I use the blue point? Let's use the blue point. Why? Because 0 is the first coordinate, which means what is this? special thing here, this is our y-intercept. And if we have the point and the y-intercept, we can just write the equation. Y equals, if we have the slope and the y-intercept, we can write the equation. Y equals negative 1250x plus 12,000. So that is the linear equation that describes the book value of the equipment each year. And if I wanted to know how much the equipment was worth in year 5, I would just substitute in 5 for x. So x in this case is the number of years that the equipment exists. Okay, let's predict sales per share. So the sales per share for Starbucks Corporation were $6.97 in 2001 and $8.47 in 2002. So using only this information, write a linear equation that gives the sales per share in terms of the year. Then use that to predict the sales per share for 2003. So again, we need to figure out, do we have some points here? We do, because we're going to have the year and then the sales. That's the way our point is going to work. Why did I put year first? Generally because time, like years, is always going to be an independent variable. It's always going to be x. You'll find that as you go through math and physics and chemistry, etc. Biology, when you're doing tests and experiments, time is always an independent variable. Okay, so our points are 2001, $6.97, and then 2002, $8.47. So if we're going to find the slope between those, I'm going to do 8.47 minus 6.97 over 2002 minus 2001, which gives us 1.5 over 1, which equals 1.5. So our slope is 1.5. Again, this is money, because this is basically, think about this. Our units up here were money, and our units down here are years. So this is money per year. That's our rate of change. So $1.50 per year is what's changing. Okay, that being said, we could just add $1.50 to $8.47. And if we do that, we would get, we should get our value. But let's do the math. So our equation is going to be slope-intercept form eventually, but we first need to find out what our y-intercept is because we don't know it yet. So you can either calculate it by plugging in a slope-intercept and solving for the y-intercept, or just use point-slope form and transform it. So I'm going to do y minus 2,000, no, I'm not. Y minus 6.97 equals 1.5 x minus 1. Why am I doing 1? Because 1 year passed. Okay? All right, if I multiply these things all out, y minus 6.97 equals 1.5x minus 1.5, and I'm going to add the 6.97, that's a 7, to both sides. So y equals 1.5x minus, plus 5.47. So that's our equation. Then if we want to predict the sales share per year for 2003, in here we would put 3 because that is years after 2000. if 2001 was 1, then 2002 is 2, and 2003 is 3, etc. All right, so anyways, if you plug in 1.5 times 3 plus 5.47, and you get $9.97. So that is an estimate for the sales share for 2003.